now move into our discussion of Chapter 5, the analysis of covariance. And we want to examine the material and so that we understand it more fully. Now, in the analysis of covariance, we need to review our types of variables as we work through this. First of all, we need to remember that an independent variable is the treatment or the intervention variable. And this is the one that's manipulated. And that's what we need to understand. And during the independent variable, this does not change. And so that's the way that you look at deciding what is an independent variable. This is the variable that does not change during the research. And in Chapter 11 of your textbook for 9615, you have a discussion of independent and dependent variables, which we're going to look at momentarily. Then we have the dependent variable. Now, this is the observed response. This is the variable that changes. So the independent variable does not change, and that's like our example that we used in factorial analysis of variance. Your year in college, for the purpose of the study, it does not change. You're always either a freshman, sophomore, junior, or senior. What did change in that was your attitude or your contentment of college life, and that changing variable is the dependent variable. And this is the one that we usually, for most cases, are looking for a score or scale data. Now, if we are using nominal data, then we would have some other aspects that we would use. But for most of what we're doing, we're looking for a scale data, and that's a score on something. Now, there are some other variables that we need to be aware of, especially as we begin to discuss ANCOVA. And this is the control variable. These are effects that can be neutralized. And this has to do with your gender, socioeconomic status, ethnicity. Those are continuous variables that can be controlled and that impact everyone. So everyone has gender, everyone has socioeconomic status, everyone has an ethnic background. And so we can control for those in what we're doing in the analysis of our independent, dependent variables. And that's what we're actually going to be doing in the ANCOVA, is mathematically removing the influence of these control variables on the independent and dependent variable. Then we have a moderator variable. This is a secondary independent variable that affects the relationship between the independent variable and dependent variable. And we will look at those types of variables later on as we discuss path analysis. And then finally, there are the intervening variables. These are variables that are there, but we can't measure them. And that's sort of that unknown variable that causes impact. And again, we're going to come back to that type of variable when we discuss path analysis. Now, let's look at how these relate with one another. So we have causes, relationships, and effects. Now, in causes, we have independent variables, we have the moderator variable, and then we have the control variables. And these are all variables that stay the same, that don't change throughout the research. These variables go through an intervening variable. And again, remember, we can't control for that, but there are some variables out there that are going to impact the effect that happens when we get to the dependent variable. So we're looking at independent variables, moderator variables, control variables, which don't change during the research project, and then we're looking at the dependent variable, which does change during the research project, and it's that dependent variable's change are the differences in the groups that we're looking at. So now we want to talk about ANCOVA, and the ANCOVA is basically going back to the ANOVA, where we have one independent variable. Now remember that independent variable is going to have 3 or more groups. And again, our example we've been using is year in college, where we have 4 groups. And we're going to have one dependent variable. That's going to be one score for each of those 4 groups. And we're being using the example of our contentment at college, contentment with college life score. So we see it's the ANOVA, but we're going to add in a control variable. And that's going to be at least one other independent variable that influences the dependent variable that is controlled for mathematically. So let's use gender as our control variable, because there may be a difference in the response that you give on the Contentment of College Life score that is influenced by your gender in a way that impacts it more, or in a way that impacts it that's other than your year in college. And so we want to take the influence of gender out of the equation mathematically, so that we can see what it is that being a junior in college has to do with the dependent variable. By controlling for this other independent variable, or a control variable, the research has given a better picture of the variance caused by the independent variable that's being investigated. The additional IV, or independent variable, are independent variables, actually you can do with more than one covariate, are local covariates. And a covariate is a continuous variables that are not part of the main experimental manipulations, but have an influence on the dependent variable. This gives you a good definition of the kind of thing that we're looking for in our covariates. Now, the purpose of the ANCOVA, why do we do the ANCOVA? Well, there are three different situations where you could use the ANCOVA. The first one is in an experimental setting. And here we use the ANCOVA to increase the sensitivity of the test of main effects of interaction by reducing the error term. And the error term is adjusted for and hopefully reduced by the relationship between the dependent. The second purpose of the ANCOVA control variable is to adjust. So what we're doing is, this is the first idea that we use ANCOVA for, is in our research. A second purpose of the ANCOVA is to adjust that we want the dependent variable themselves to what they would be if all subjects scored equally on the control variable. And usually we find this being a purpose of the ANCOVA when we have non-experimental or non-random studies. And that's one of the things that ANCOVA needs, is one of its assumptions, is that the group was selected random. When you have to violate that because of the way things are set up, you would need to explain that so that people can read your results in light of that. And thirdly, the ANCOVA is used when computing a MANOVA, and we're going to get to the multiple analysis of variance in the coming chapters. Now, how do we determine how many covariants we could use in our study? Well, if the control variable is continuous, that is, it's a score and it's scale data, you look to see if they're theoretically correlated with the dependent variable. Have they been shown to correlate with the dependent variable? And this would be through your literature review. And they should be significantly correlated, and they should have low correlations with the other ideas themselves when there's more than one covariant is used. So they shouldn't be interrelated when there's more than one covariant. Now, if the covariant is categorical, that is nominal data, then the degree of correlation is not important because you can't compute it. When the continuous variable is continuous, determine if there's a redundancy in the continuous variable. That means you've got more than you need and you start getting interactions between the control variables. Then you're going to use a squared multiple correlation. If the squared multiple correlation for the control variable is greater than 0.50, you have redundancy and should eliminate the control variables. So how do we decide that? Well, as your textbook shows you, you can use Wheatman's formula, and that's where you have C plus J minus 1 divided by N, and it should be less than or equal to 0.10. And here we have C is equal to the number of control variables, J is the number of groups, and N is the number of participants. And you adjust C until you get a rate of less than or equal to 0.10. So here's the example from page 103 in your textbook. We have a J of 3. We have an N of 45. So what control variable and how many control variables do we need to interact so that we get a result of 0.10 or less? Well, if we put 2.5 plus 2, that gives us 4.5, and we divide that by 45, that gives us a result of 0.10. And so we would want to use 1 or 2 control variables in this situation. Now, what are some threats to ANCOVA? you have unequal sample sizes. And once you've collected your data and you have unequal sample sizes, you cannot adjust that. So you would have to go to some other type of mathematical manipulation or statistic to come up with your answer. You have the absence of outliers, and this you can adjust your data set, and that's it. Part of the way we do transformations to deal with those outliers. And then we have the absence of multicollinearity and singularity. That is, these control variables don't interact with one another, or they interact so much that they act like one variable themselves. So that's where you get into this dealing with how many covariants you want to use in order to deal with this multicollinearity that may be there. Now, some assumptions. We have normality of sampling distribution. The sample means are assumed to be normal, and the central limits theorem is assumed. That is primarily that they've been selected randomly. We have homogeneity of variance. That means they work together. And then we have linearity. And we assume that the relationship is linear. And this is where we use our scatter plots, our box plots, to see that we have a linear relationship. Moving on, we have a homogeneity of regression. That is, the slopes are equal. And then we have the reliability of the covariance. And we assume that the covariance have been measured without error. Now, in the example that I saw where if you report your gender, you're going to be pretty reliable about that. If you're going to report your ethnicity, that'll be a pretty reliable response. There are some of these covariants that may introduce some error, like people may not know which of their socioeconomic status they really should go into, and so they might make some error there, but you assume that it has been reported reliably. One of the first things you do in the ANCOVA is that you're going to conduct an ANOVA, and if you find a significant ANOVA, then you don't proceed with the ANCOVA because you got the results you want and you don't need to control for that other variable. Now, interpreting the results, we're going to go through that in the video where we work out the problem that's in your textbook, and we look at the results that we get from SPSS and how we report and what we report on.